Sanjay Kumar. He completed his BE Civil Engineering from Madurai Kamaraj University. He also pursued his ME Soil Mechanics and Foundation Engineering from Anna University, Chennai. He worked as a designer engineer for 1 year under a structural consultant in Madurai. He is currently working as a faculty member in the Department of Civil Engineering, Tyagarajar College of Engineering, Madurai. He has organized 2 national conferences at TCE in 2010 and 2014. He's also got 3 publications in international journals. He is an A-lead member for the Geotechnical Consultancy at Tyagarajar College of Engineering.
Welcome to UGC lecture series for architecture. We are going to see Mechanics of Structures 1, in which the first unit will be Forces and Structural Systems. So, this is lecture number 3. Contents of the lecture this lecture would be Principle of Moments, then we will be seeing about Varignon's theorem, and finally, we will be seeing application of the Principle of Moments and Varignon's theorem to solve problems. Principle of Moments: when an object which is acted upon by several forces is in equilibrium, the sum of all clockwise moments will be equal to the sum of all anti-clockwise moments. Let us consider a 2-dimensional plane figure which is subject to several forces like this. Now, this planar figure is subject to 3 forces, namely F1, F2 and F3. Perpendicular distances of these 3 forces with respect to a point O. Now, this is the point O. Perpendicular distances for these 3 forces with respect to point O are small r1, small r2 and small r3. That is, perpendicular distance between O and F1 is small r1, and the perpendicular distance between F2 and O is small r2, and the perpendicular distance between F3 and O is small r3. Now, according to the principle of equilibrium, here this object is subject to 3 forces, and if this object is in equilibrium, then algebraic sum of all clockwise moments about O will be equal to algebraic sum of all anti-clockwise moments. Hence, according to this theorem, now let us consider the force F1. Force F1 about O creates a clockwise moment. Now, this is point O and the force F1 acts like this. So, it induces a clockwise moment with respect to O. So, let us keep clockwise moments as positive mean. Now, let us compute all the clockwise moments. So, we are computing all the clockwise moments first. F1 creates a clockwise moment about O. Perpendicular distance between F1 and the point O is small r1. So, the clockwise moment would be F1 into r1. Now, let us consider the second force, that is F2. Here is the point O. F2 acts like this. Once again, F2 creates a clockwise moment with respect to point O. So, to the first clockwise moment F1 into R1, we will be adding the moment due to F2. So, it is F2 into R2. So, F1 and F2 are the 2 forces which are giving clockwise moment with respect to O. Now, let us consider the force F3. So, here is our point O, F3 acts like this. So, it induces an anti-clockwise moment with respect to O. F3 is the only force which gives the anticlockwise moment. That anticlockwise moment with respect to O will be F3 into R3. Since this planar figure is in equilibrium, sum of all clockwise moments will be equal to sum of all anticlockwise moments, and hence F1 R1 plus F2 R2 will be equal to F3 into R3. So, this is known as principle of moments. Now, we shall see about Varignon's theorem. According to this Varignon's theorem, moment of the resultant of all the forces about a point is equal to the algebraic sum of moments of all the forces about that point. Now, let us consider two forces meeting at a point. The resultant for these two forces will be like this. The resultant for these two forces F1 and F2 will be the diagonal of the parallelogram passing through the intersection point O. So, R is the resultant here. Now, let us consider any point P. Perpendicular distance between the force F1 and P be small r1. Perpendicular distance between the resultant capital R and the point P, let it be small r. And finally, the perpendicular distance between the force F2 and the point P be small r 2. So, this angle will also be 90 degree. Similarly, this angle is 90 degree. According to Varignon's theorem, moment of resultant of all forces about P, here the resultant is capital R, hence the moment of resultant about P will be capital R into small r. Moment of resultant of all the forces about P will be equal to algebraic sum of moments of all forces about P. Algebraic sum of moments of all forces about P will be F1 into small r1 plus F2 into small r2. Here for both the moments positive sign is coming because both F1 and F2 will induce clockwise moment with respect to point P, and hence we have positive signs for those two moments. Similarly, the resultant R will also induce clockwise moment with respect to P, and hence positive sign is coming for the resultant moment. So, this is the statement according to Varignon's theorem. Now, we shall see the application of principle of moments and Varignon's theorem to solve some problems. Let us see the first problem. Four parallel forces of magnitudes 100 Newton, 200 Newton, 50 Newton and 400 Newton acts on a straight line ABCD as shown in the figure. Determine the magnitude of the resultant and also the distance of the resultant from point A. So, in this figure there is a line ABCD. Over the line ABCD we have four parallel forces acting. These are unlike parallel forces. Magnitude of the four forces are shown in the figure. Also the distances between the four forces are also shown in this figure. We are asked to determine the magnitude of the resultant and also its position. Magnitude of the resultant will be easily obtained by determining the algebraic sum of all vertical forces, algebraic sum of all forces. But in order to determine the position of the resultant, we have to use Varignon's theorem. Now, let us see the solution for this. So, this is the line ABCD in which 4 forces are acting. Distance between the forces are given. The resultant of all the forces will be computed like this. We will be taking all the forces going in the upward direction as positive, hence forces going in the downward direction will be taken as negative sign. Now, we shall consider the first force, which is 100 Newton, which is going in the upward direction. So, positive sign will be coming for that 100 Newton. The next force 200 Newton goes in the downward direction. So, negative sign will be coming for that force. Similarly, negative sign will be coming for the third force, which is 50 Newton. And finally, the fourth one goes in the upward direction, 400 Newton force goes in the upward direction. So, positive sign will be coming for that force. So, basically resultant for parallel forces will be the algebraic sum of forces. So, here the 4 forces are parallel forces and hence the resultant is nothing but algebraic sum of all the forces. So, the resultant works out to be 250 Newton. If you see the sign of the resultant, it comes as positive sign and hence the direction of the resultant will be in the upward direction. Okay. So, let us mark the resultant on the line ABCD. The resultant may be acting anywhere between A, B or B, C, or it can be between C and D. We do not know the exact position of that resultant. So, what we are going to do? I am going to arbitrarily assume the position of the resultant. It is somewhere between B and C. So, this is the resultant. Magnitude of the resultant is 250 Newton. Resultant acts in the upward direction. Let the distance between the resultant and point A be x. I am denoting the distance between point A and the resultant as x. So, by Varignon's theorem, moment of the resultant about a certain point, here I am going to consider point A, moment of the resultant about point A will be equal to algebraic sum of moments of all other forces about point A. Moment of R about point A will be 250, perpendicular distance between R and point A is x, 250 into x. Now, this is point A, resultant acts like this. So, about point A R induces anticlockwise moment. So, I am going to put a negative sign for this anticlockwise moment. So, this is the moment of resultant about A. This should be equated to algebraic sum of moments of all other forces about A. Now, let us consider this 100 Newton force first. 100 Newton force passes through A, hence it does not have any lever arm, that is perpendicular distance. Hence, moment due to 100 Newton force about A will be 0. Next, we shall consider this 200 Newton force. 200 Newton force creates, this is point A, 200 Newton force is acting like this. It induces a clockwise moment. Anti-clockwise moment is taken as negative and hence clockwise moment will be taken as positive. So, it will be 200 into perpendicular distance between 200 Newton and A is 1 meter. So, into 1. Similarly, for the 50 Newton force once again creates a clockwise moment about A. So, the moment will be 50 into perpendicular distance will be 1 meter plus 1.5 meter, which is 2.5 meter. And finally, this 400 Newton force creates an anti-clockwise moment about A. So, anti-clockwise moment we have to put negative sign. So, this is 400 into perpendicular distance between 400 and point A is 3.5 meters. So, from this if you calculate, x comes as 4.3 meter from the point A. So, this x is calculated as 4.3 meter. So, for this given force system we have calculated the magnitude of the resultant as well as is position with respect to the point A. For this problem we have applied the Varignon's theorem. We shall see one more problem. 4 forces of magnitudes 20 Newton, 40 Newton, 60 Newton and 80 Newton are acting respectively along the 4 sides of a square A, B, C, D as shown in the figure. Determine the resultant moment about the point A. Each side of the square is 2 meter. The figure shows a square ABCD of side 2 meter. Along the 4 sides we have 4 different forces acting. Along the side AB we have a force of magnitude 20 Newton. Along the side BC we have a force of magnitude 40 Newton. Along CD there is a 60 Newton force, and finally along DA we have 80 Newton force. We are asked to determine the resultant moment of all the 4 forces about point A. Resultant moment of all the forces will be the algebraic sum of moments of all forces about point A. So, we shall construct the square along with the 4 forces. Resultant moment about point A will be equal to algebraic resultant moment about point A will be equal to algebraic sum of moments of all forces about A. Once again we are going to use Varignon's theorem. First of all we shall consider this 80 Newton force. 80 Newton force passes through point A, hence it does not have any perpendicular distance, that is lever arm. So, moment due to 80 Newton force about A will be 0. Next we shall consider this 20 Newton force. If you see this 20 Newton force, this 20 Newton force is also passing through point A, and hence it does not have lever arm. So, the moment due to 20 Newton force about A will also be 0. Now, let us consider this 40 Newton force. 40 Newton force, we shall extend that force. So, this is the line of action of this 40 Newton force. Perpendicular distance between this 40 Newton force and point A is this distance, which is this side dimension of the square, which is 2 meter. So, naturally 40 Newton force creates a moment about A. That moment will be an anticlockwise moment. So, the moment will be 40 into 2. Since it is an anticlockwise moment, we shall put a negative sign here. Now, let us consider the final force, which is 60 Newton force. 60 Newton force acts along the side DC. It does not pass through point A. Perpendicular distance between this 60 Newton force and point A is once again the side dimension of the square, which is 2 meter. 60 Newton force once again creates a anticlockwise moment about A, and hence we shall put a minus sign. So, minus 60 into 2. So, 40 into 2 is 80, 60 into 2 120. So, we get minus 200 Newton meter. So, this is the resultant moment of all the 4 forces about point A. Minus sign indicates that the nature of this resultant moment is anticlockwise. Now, we shall summarize the things which we have learnt in this third lecture. We have seen an overview about the principle of moments and Varignon's theorem. Also, we have seen the application of principle of moments and Varignon's theorem to solve two problems. Questions for the students to answer: explain the principle of moments, state Varignon's theorem. They can also try this problem. Three parallel forces F1, F2 and F3 are acting on a body. Actually, it is a straight line as shown in the figure, and the body, that is the straight line, is in equilibrium. Determine the magnitude of the force F2 and the distance of F3 from F2. So, the object or the straight line is ABCD, in which we have three forces acting, F1, F2 and F3. Magnitudes of F1 and F3 are given. F2 is the unknown force. Also, the distance between F2 and F3 is not given. So, you are asked to determine the magnitude of the unknown force F2 and the distance between the force F2 and F3. To solve this problem, we will be using once again Varignon's theorem. This comes to the end of the third lecture. Thank you.